Wabarakatuh. I'm Hassan Al-Shaqwir, and today I'm going to present the MIS-377 final project, KAU, or this course registration system, analysis and redesign. Group members, Muhannad Al-Amoudi, Muhammad Nagro, and Hassan Al-Shaqwir. Moving to slide 3. The system background. The KAU audit system is the primary online academic platform used by students to register for courses, view schedules, and manage academic requests. It plays a critical role in organizing the registration process and helping students complete their academic plans. However, students frequently encounter issues during registration periods, especially during peak times when thousands of users access the system simultaneously. Next slide. Issues in the current system. The first issue is system crashes, frequent outages during peak registration periods due to high concurrent user load. Second, slow responses times, significant delays when submitting or confirming course registrations. Third, unclear prerequisite checks. Prerequisite validation is inconsistent and often unclear to students. Fourth, no real-time seat updates. Seat availability is not updated in real time, leading to failed registrations. Fifth, limited advising integration. Difficult change requests. Limited advising integration, weak integration with academic advising tools and support workflows. Last but not least, difficult change requests. Submitting and tracking course change requests is cumbersome and non-transparent. And thank you for listening.
Assalamu alaikum wa rahmatullahi wa barakatuh. In this slide, I will continue with the current system data flow diagram, or DFD. For the KAU ODIS course registration system, the diagram explains how data moves between students, advisors, admins, system process, and database during the registration process. First, students log into the ODIS system using their login information. The system verifies the student data using the student record database. After logging in, student can view available courses, register for courses, view their schedules, and submit course change request. The system retrieves course information from the course database and stores registration information inside the registration records database. If a student submits a course change request, the request is stored in the course change request database and then reviewed by the advisors. Administration are responsible for managing and updating course information inside the system. Overall, the current system supports the basic registration functions, but it still depends on limited automation and manual review process, which may lead to delays and registration issues during peak periods. This slide shows the current system used case diagram for the KAU audit system. The diagram illustrates the interactions between the main actors and the system. The first actor is a student. Student can log into the system, view available courses, register for courses, view their schedules, and submit courses change requests. The second actor is advisor. Advisors mainly review courses change request and decide with their approve or reject them. The third actor is admin. Administration manage course information and update course sections inside the system. The use case diagram also shows the relationship between some system functions using include and extend relationship. For example, The register for course functions include viewing available courses, while approving or rejecting a course change request, extend the review process. Overall, the diagram demonstrates the current system providers and the main registration service, but still lacks advanced automation, intelligent recommendation, and strong advising integration. And that's all for my part. And now I'll hand it to my colleague Muhammad Al-Amoudi.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Muhammad Al-Amoudi. In my part of this presentation, inshallah, I will continue by explaining first the proposed system DFT. This slide shows the proposed DFT we have made for the improved system. In the new system, the student can log in, view recommended courses, check prerequisite, see real-time seat availability, register for courses, and view the schedule. The system uses more data stores such as student academic record, course database, prerequisite rules, seat capacity records, and advisor notes. The main improvement is that the system checks important information automatically before registration. This helps reduce mistakes and makes registration faster and clearer for students. Moving on to the next slide, which is proposed system use case. And this slide shows the proposed use case diagram. The main actors are still the same, which is student, advisor, and admin. The student can use new features such as viewing recommended courses, checking prerequisite, checking seat availability, and registering for courses. The advisor can view student academic reports, view student plans, and add advising notes. Lastly, the admin. The admin can manage courses, update course capacity, manage prerequisite rules, and monitor the system. Overall, the proposed system gives students better support and makes the registration process easier and more reliable. We'll go on to the next slide, which is our benefit analysis. We have tangible benefits, which is faster registration process with reduced wait time, reduced server downtime during peak periods, fewer registration errors and conflict, improved course seat management and allocation, overall better system performance and stability. For the intangible benefits, we have a higher student satisfaction and confidence, reduced stress during registration period, better communication with academic advisors, improved long-term academic planning, enhanced overall user experience. Moving on to the next slide. This is our proof that we use Lucid chart for making the data flow diagram and use case diagram for the current and proposed diagrams. The next slide shows that we use ChatGPT to identify the processes for our proposed diagrams. Now we have reached to the end of our presentation. Thank you for listening.